National Electrical Code (NEC) mandates grounding for all portable generators. This is a critical safety measure designed to protect individuals from electrical shock and to prevent the generator itself from becoming energized in the event of a fault. The primary method for grounding a portable generator involves the installation of a ground rod. The NEC specifies that this ground rod must be driven into the earth to a minimum depth of 8 feet. The material of the ground rod is also specified. It must be either copper or stainless steel to ensure adequate conductivity and resistance to corrosion. Furthermore, the ground rod must have a diameter of at least 5/8 inch to provide a sufficient contact area with the earth. Connecting the ground rod to the generator frame is accomplished using a ground wire. This wire creates a conductive path between the generator and the earth, allowing fault currents to safely dissipate. In addition to the dedicated ground rod, the NEC recommends connecting the generator to the site's existing grounding system if available. This supplemental grounding can be achieved by linking the generator's ground wire to a pre-existing grounding electrode system, such as a grounding rod installed for the building or the metal water pipe entering the building, provided that water pipe meets the requirements outlined in the NEC. There are several key reasons why grounding portable generators is so important. Firstly, it provides a low impedance path for fault currents. In the event of an insulation failure within the generator or connected equipment, the fault current will flow through the ground wire and into the earth, rather than through a person who might come into contact with the energized equipment. This rapid flow of current typically trips a circuit breaker or blows a fuse, quickly de-energizing the circuit and preventing a potentially fatal electric shock. Secondly, grounding helps to stabilize the voltage of the electrical system. Without a proper ground connection, the voltage can fluctuate wildly, which can damage sensitive electronic equipment. A stable voltage is crucial for the reliable operation of tools, appliances, and other devices powered by the generator. Thirdly, grounding minimizes the risk of static electricity buildup. Static electricity can accumulate on the generator frame, particularly in dry environments. If this static charge discharges through a person, it can cause a painful shock. Grounding provides a path for static electricity to dissipate harmlessly into the earth. Understanding the NEC requirements for grounding is crucial for anyone using portable generators. The specific sections of the NEC that address grounding requirements include Article 250, which provides the general rules for grounding and bonding, and Article 445, which covers generators. These sections outline the specific requirements for ground rod size, material, installation depth, and wiring methods. When selecting a location for the ground rod, it's important to choose a spot where the soil is consistently moist. Moist soil provides better conductivity than dry soil, which improves the effectiveness of the grounding system. Avoid locations near underground utilities such as water pipes or gas lines to prevent accidental damage during installation. The installation process involves driving the ground rod into the earth using a ground rod driver or a hammer. Ensure that the top of the rod is flush with the ground or slightly below the surface to prevent tripping hazards. Once the ground rod is installed, connect the ground wire from the generator frame to the ground rod using a suitable clamp or connector. Make sure the connection is tight and corrosion resistant. If connecting to the site's grounding system, use a similar clamp or connector to attach the generator's ground wire to the grounding electrode. Inspect the entire grounding system regularly to ensure that all connections are secure and free from corrosion. Replace any damaged or corroded components immediately. It's also a good idea to test the grounding system periodically using a ground resistance tester to verify that it is functioning properly. If you are not comfortable installing a ground rod or connecting to the site's grounding system, it is always best to consult with a qualified electrician. An electrician can ensure that the grounding system is installed correctly and that it meets all applicable codes and regulations. Improper grounding can create a dangerous situation, so it's important to take the necessary precautions to ensure safety. Ignoring the grounding requirements for portable generators can have serious consequences. In addition to the risk of electric shock, improper grounding can also damage the generator and connected equipment, leading to costly repairs or replacement. It can also create a fire hazard if fault currents are not properly grounded. Some portable generators are equipped with a neutral bonding plug. This plug connects the neutral conductor to the generator frame. When using a generator with a neutral bonding plug, it is important to understand when to remove the plug. In general, the neutral bonding plug should be removed when the generator is connected to a separately derived system, such as a transfer switch that isolates the generator from the utility power. Removing the neutral bonding plug prevents circulating currents and ground loops, which can cause nuisance tripping of circuit breakers and damage to equipment. When using a generator as a standalone power source, the neutral bonding plug should remain in place. This ensures that the generator is properly grounded and that fault currents will flow through the grounding system. The NEC provides specific guidelines for determining when to remove the neutral bonding plug. If you are unsure whether to remove the plug, consult with a qualified electrician. Many job sites have specific requirements for grounding portable equipment. Before using a generator on a job site, check with the site supervisor or safety officer to determine if there are any specific grounding requirements that must be followed. Some job sites may require the use of ground fault circuit interrupters, GFCIs, to protect workers from electric shock. GFCIs are designed to detect small imbalances in current flow and quickly shut off power to the circuit, preventing a potentially fatal shock. If GFCIs are required, make sure they are properly installed and tested before using the generator. Other job sites may require the use of equipment grounding conductors (EGs) to ground portable equipment. EGs are wires that connect the metal frames of equipment to the grounding system, providing a low impedance path for fault current. If EGs are required, make sure they are properly connected to the equipment and to the grounding system. In addition to grounding, it is also important to follow the safety precautions when using portable generators. Firstly, never operate a generator indoors or in a confined space. Generators produce carbon monoxide, a deadly gas that can build up to dangerous levels in enclosed areas. Always operate the generator in a well-ventilated area, away from windows, doors, and vents. Secondly, keep the generator dry. Never operate a generator in the rain or snow. If the generator gets wet, it can create a shock hazard. Protect the generator from the elements by placing it under a canopy or in a shed. Thirdly, never refuel a generator while it is running or hot. Allow the generator to cool down completely before refueling. When refueling, use a funnel to prevent spills and wipe up any spills immediately. Fourthly, store fuel safely. Store gasoline in approved containers away from heat sources and open flames. Never store gasoline in the same area as the generator. Fifthly, inspect the generator regularly. Check for loose wires, damaged cords, and fuel leaks. Repair any problems immediately. Sixthly, use the correct size extension cords. Using undersized extension cords can cause the generator to overheat and create a fire hazard. Use extension cords that are rated for the amperage of the equipment being powered. Seventhly, protect extension cords from damage. Avoid running extension cords through doorways or under rugs, where they can be pinched or damaged. Eighthly, never overload the generator. Check the wattage rating of the generator and do not exceed it. Overloading the generator can damage it and create a fire hazard. Ninthly, use a carbon monoxide detector. Install a carbon monoxide detector in the area where the generator is being used to warn you of dangerous carbon monoxide levels. Tenthly, have a fire extinguisher nearby. Keep a fire extinguisher readily available in case of a fire. In conclusion, grounding portable generators is a critical safety measure that is required by the NEC. Grounding protects individuals from electric shock, prevents damage to equipment, and reduces the risk of fire. By following the NEC requirements and taking other safety precautions, you can use portable generators safely and effectively. Always consult with a qualified electrician if you have any questions about grounding or electrical safety. Remember that electrical safety is paramount and should never be compromised.